Hello everyone. In this lecture we will discuss field lines, flux and Gauss law. To understand this, suppose we have a single point charge Q situated at the origin. For this, electric field ER, this is equals to 1 over 4 pi epsilon naught into Q over R square into R cap. So this is clear from this expression that when the distance increases, the electric field goes on decreasing. This we can visualize with the help of this figure. For example, suppose we have this point here. This is a point where charge is situated, and suppose we represent the electric field with the help of a arrow. Then it is observed from this, as we move away from the origin, the electric field goes on decreasing. That is, the length of the this arrow goes on decreasing. Similarly, on this side or on this side or here and diagonally also. So first point, it shows that as we move away from the charge, electric field goes on decreasing. And second point here is the direction of the electric field is away from the charge, that is, it point radially outward. So this is the case for electric field, and here we have one equivalent diagram. That is, suppose here we have a charge it shows that again the electric field move away from the origin, that is radially outward. But from this figure it seems that some information is missing, that is the strength of the field is missing. But actually the strength of the field, it depends upon the density of lines. Okay, so it depends upon the density of the lines. So here near the origin, the number of lines here are more as compared to the here at this point when we move away from the origin, and so on. That is, in this first circle the density is more as compared to the second circle, and in third circle, and so on. So again it give the same information, that is that field strength of field goes on decreasing as we move away from the origin or from the charge. So next point here is actually this is a two-dimensional picture, and this two-dimensional picture is deceptive. Deceptive means this is a misleading. Why it is misleading? Because here we have a two-dimensional picture. Because we have two-dimensional picture, then we have a circle, and in case of a circle we have a circumference. That is, here in this case density of lines is equals to number of lines per circumference, that is 2 pi r. So here we have a r, but in our actual expression we have a r square. So in place of a two-dimensional picture we require three-dimensional picture. That is, we have a spherical ball. Then in case of three-dimensional picture, then density of lines is equals to number of lines per 4 pi by 4 pi r square, that is area of the sphere. Okay, so it shows the same that is r square as we observed in the our real expression, that is 1 over 4 pi epsilon naught into q over r square into r cap. Now this will give the same information as we expect from our electric field equation. Next point here is, so here suppose we have a one positive charge and then one negative charge. Then the lines, field lines begins on positive charge and end on the negative charge, like this. Similarly we have here. And the direction is from positive to negative. This is the case when we have equal but opposite charges. So when we have equal and opposite charges, then the field lines start from the positive charge and end on the negative charges. Now here, if we have equal charges, that we have the same charges with same magnitude, then the direction of the field lines are like this, that is their similarly on this side. So this is the case when we have equal charges. Okay. Now here, as per this model, mathematically flux is equals to E dot dA, and here we have a surface integral. So here this dA is the infinitesimal area, and here according to this, flux is proportional to the density of lines, that is the number of lines per unit area. Okay, so here the total flux basically consider the total charge enclosed within the closed surface. So here the charge outside the surface will not contribute in the total flux. So here, total flux measure or depends upon the total charge present inside the closed surface. So if we have a charge outside the surface, then it will not contribute in the total flux. Or mathematically we can write like this, that is E dot dA surface integral. Suppose we have a closed surface, then this is equals to 1 over 4 pi epsilon naught into Q over R square R cap. This is the value of electric field, and here we have a dA, that is closed surface. So because here this is a sphere, this is a three-dimensional picture, so we can write 1 over 4 pi epsilon naught Q over R square R cap, and dA, that is the area of the sphere, this is equals to 4 pi R square. So here 4 pi is cancelled with the 4 pi, so we can write, or R square is cancelled with R square, so we can write 1 over epsilon naught into Q, that is E dot dA closed surface area is equals to 1 over epsilon naught time the charge. This is the case when we have a single charge. Now in actual practice, we have a number of charges, that is for bunch of charges we can write E, the total electric field, equals to summation I equals to 1 to n, and here we have EI, that is I equals to 1 to n. 1 is the electric field for the first charge, E2 is the electric field for second charge, E3 is the electric field for third charge, and so on. So finally we can write that is E dot dA, this is equals to summation I equals to 1 to n, and here we have a integral that is EI dot dA, or because this term is equals to 1 over epsilon naught into q, so we can write summation I equals to 1 to n and qi over epsilon naught. Okay, or finally we can write, to generalize this expression, we can write E dA, this is equals to q over epsilon naught. This is a enclosed. So here q enclosed is the total charge enclosed within the surface. Okay, the total charge enclosed within the surface. So this is a Gauss law in integral form. So what is a Gauss law? So here Gauss law states that the net electric flux through any closed surface, any hypothetical closed surface, is equals to 1 over epsilon naught times the total charge enclosed within that surface. Okay, so what is a Gauss law? Gauss law states that the net electric flux through any hypothetical closed surface is equals to 1 over epsilon naught times the total charge enclosed within that surface. So here in this lecture we discussed the field lines, flux, and finally Gauss law. Thank you.